So this video is going to summarize all the things that we've talked about with regards to inequalities, both the symbols and how we find the solutions and what that looks like on a number line as well as with those symbols. The symbols include the less than symbol. Notice it's like your hand holding up an L. Less than, without the equal sign underneath it, would indicate that 5 is not a solution. So less than is going to be the numbers like 4, 3, 2, 1, 0. And so we have put an open circle there because it does not equal. The minute that it says x is less than or equal to 5, that's this equal sign also means that 5 works, and that's when we use our closed circle. So equal sign as part of it is a closed circle. If it doesn't have the equal sign, then 5 is not a solution, but it's an important part of the written part. By the way, this is the algebraic part with the symbols there, and then the number line is just the way we write it since there's so many solutions. Greater than, once again, greater than, think of moving in a positive direction. That arrow is going in a greater direction. 5 in this case is not a solution, so we would go ahead and put an open circle. And greater than are the numbers like 6 and 276. And so we would go ahead and show all those numbers by shading in that direction. Greater than or equal would include that part there, which means we would include 5 as part of our solution. That's why we use a closed circle. Solving inequalities. They almost always have more than one solution. So if we talk about x has got to be greater than 2, there's an infinite number of numbers that are greater than 2. We have 3, 4, 5, 6 million, gazillion, bajillion. Sometimes we have a compound inequality, like we did when we were talking about driver's licenses, and you can have your license without with a permit from the time you are greater than or equal to 15 and a half, but you don't need a permit if you're 18. So you could go ahead and talk about the solutions being equaling 15 and a half all the way up to 18, but at 18 you don't need a permit, so it would be any age from 15 and a half up to the day before your 18th birthday, but who would do that? So there's not an infinite number of solutions to this one, but there's lots of solutions, anywhere from 15 and a half to 16 and a quarter, etc. So when we can talk about, let's go back to the license idea, we can say that you can get your permit at 15 and a half, you can get your permit at 16, you can get your permit at 17 and a half. Who would do that? I don't know. You can make a list, or we can talk about the symbols. X has to be, or age in this case, I might as well use a variable that makes sense. Your age has to be greater than or equal to 15 and a half, and then a less than 18. So I push those two symbols together to talk about the whole thing. And then, of course, we can write that with a dark circle at 15 and a half because that counts as one of the solutions, and then an open circle again at 18 because it doesn't. So this is algebraic right there. This part is the algebraic way with symbols, and this is your number line, which shows all the possibilities. The steps to solving inequalities are similar. The first two steps are the same as solving equations. When you have a complicated equation, you want to simplify each side, whether that means adding like terms or that means distributing. Even it could mean just rewriting it so you're not confused by some negative signs or something like that. Just making sure that you have an equal statement. So it's easy to do. Then you can either figure it out by looking at it, because sometimes you can just see the answer. And you're finding the boundary point. You might need to use opposite operations to get that variable by itself, and then to find the boundary point. And then we're going to go ahead and look how they're different. And they're different starting right here. Inequalities are different starting right here, because we have to deal with all of those solutions that we want. So first thing you have to do is just make things easier on yourself. Simplify each side. So in this case we have some like terms that we can write in. Maybe it's even easier for you first if you write all of them next to each other and get rid of the subtract 6x. And just think of it as negative 6x plus 3x plus 6. You may not need that, but it helps some people. And then we can just look at these like terms, and there it's a negative 3x plus the 6 is less than 12. Much easier to look at than that. So now we've already simplified each side. Now we're going to find the boundary point. And we can do that with, if we can just see the answer, that has to be negative 2, because negative 3 times negative 2 is 6, and 6 plus 6 is 12. Fine. If not, use your opposite operations. We're going to go ahead and always look to get this by itself, so we're going to start here. Subtract 6 on both sides, get negative 3x, and 12 minus 6 is 6. I'm kind of just putting that inequality symbol in there as a place marker, but I know I need to think about it a little differently in a moment. We're going to go ahead and get rid of this multiplication by dividing. And so at this point, we know that the boundary point is 6 divided by negative 3, which is negative 2. So, we want to find out if this negative 2 that we have here is part of the solution set. And since the original equation was 3x plus 6 minus 6x is less than 12, we're going to look to see if negative 2 is a solution. Since there is no equal sign there, negative 2 is not a solution, it's just the boundary. So we're going to go ahead and start our solution set here. Open circle.